Hello, I'm Dr. Uksan Kim. In this video, we will be discussing the truss analysis using the method of sections. This slide shows the overview of my lecture. In the beginning, I will talk about the general guidelines for method of sections. Then, you will learn about the free body diagrams for sections and method of section. After these slides, I will solve an example problem with detailed explanation. Finally, I will provide a practice problem to check the level of your understanding related to this topic. The method of sections is an efficient method when we need to find the force in only a few members. So, to find the force in only a few members. For this method, a truss needs to be cut. For example, in this figure, you want to know the member forces for member BC, GC, and GF. So only 3 members. In that case, instead of the method of joint, using the method of sections, the first step is to cut the members, like this. Okay, so there's a cut the truss. So maximum number of unknown forces for a section should be 3 because 3 equations of equilibrium can be used for the method of sections. So that is a sigma fx equals 0, sigma fy equals 0, and sigma m equals 0. As you know, the method of sections is using the 3 equilibrium equations, but the method of joint, in the case, then you can only use the 2 equilibrium equations, sigma fx equals 0 and sigma fy equals 0. For the method of sections, once again, maximum number of the unknown forces should be 3 because you can use the 3 equilibrium equations. This slide gives the important guidelines related to the free body diagrams for sections. So decide how to need to cut the truss. This is the very important first step. Then all forces acting on a chosen section should be included in a free body diagram. All dimensions should be included. For example, distance, angle, and then indicate the unknown forces at the cut members. Assume that all unknown member forces act in tension. That is a very important thing because this is just we use the assumed direction in tension. That is the outgoing toward the joint or cut member. You can see that for this kind of same example of this figure, okay? And then cut AA, right? And then you can have a part 1 and then part 2 of the truss. The part 1 is that the unknown, 3 unknowns, that there's a FBC, FGC, and then FGF. Okay? And then, as I mentioned, from these guidelines, you need to put the dimensions. Okay? And so there's a distance, and then also angle. And then you also put the external load, right? So in this case, you choose part 1. You don't need to find the unknown reactions at the D and E. But if you choose the section 2, in the case, you need to find the unknown reactions first with the entire truss. Okay, so because with this free body diagram, part 2, you can see that FBC, FGC, and FGF, there's already 3 unknowns. So there's cannot be the more than 3 unknowns. So that's the reason why actually these support reactions, you need to find it first. So I will explain this one using an example problem. And then once again, the assumed direction, intention, that is a very important one. So you can see that FBC, FGC, that is at the already assumed tension. So there's an outgoing from the cut members. But the F, that one, not this way, okay? Just in this direction, okay? So that is the correct assumed direction. Same thing for this side of the part 2. Also, that is the correct assumed direction for the FGF. So this slide provides a step-by-step procedure to find member forces using the method of sections. The step 1 is to decide how you need to cut the truss and which side of the cut truss will be easier to work with. Step 2 is to determine any necessary support reactions by drawing the free body diagram of entire truss and then applying the equations of equilibrium and find the unknown reactions if required. Okay, so the previous one I already explained about that, but the part 1, you choose this part in the part 1, you don't need to find the unknown reactions, but you choose the part 2, and then you need to find the unknown reactions. And then draw the free body diagram. Step 3 is to draw the free body diagram of the selected part of the cut truss. You may assume all members in tension once again. That one is the type. Okay. And then step 4 is to apply the equations of equilibrium to the selected cut section of the truss to solve for the unknown member forces. This slide shows an example problem. And then this one asks about determine the force in members BC, HC, and HG. So that you don't need to find all member forces, just only forces of the 3 members, BC, HC, and HG. So HG, right? And then HC, and then BC, okay? And then this one also asks about the state if these members are in tension or compression. So we do this one using the method of section because ask for the member forces for only 3 members. So in the case, best way is to cut the member this way. So you can choose actually the left side or right side. But you can see that this is a roller support. So there's an unknown reactions. And then E is a pin support. There's also unknown reactions. So choose the left side or right side. No matter what, you need to find the unknown reactions. Because you cut the members, these members already have 3 unknown member forces. Okay, so that's the reason why the A mentioned about draw the free body diagram for an entire truss and then find the reactions. So that is the required for to solve this problem. So this is the solution to find the support reactions. So draw the free body diagram for an entire truss. So this is the free body diagram of the entire truss, just entire truss, okay? And then you can see that there's a AY, there's a unknown reactions because this is roller, just one. And then EY and EX support E. So that one is the two unknown reactions because this is a pin support. So now this is the free body diagram and using the sigma MA equals 0. So that means that this is the A is a pivot point. So that one is that the two in this force cannot create a moment. AY cannot create a moment, right? So that one cannot create a moment and that cannot create a moment. But 4, is that the 4 in the moment arm is that the 2 and then rotate the clockwise. So counterclockwise is positive, so there's a minus sign there. And then 15 times, and then 4, there's a moment arm, the clockwise, so there's a negative sign. 10 times, 6, there's a negative, and then 5 times, 8. And then EY also create a moment, EY times 8, but that one is the counterclockwise, so there's a positive sign, okay? So with this kind of calculations, you can see that easily, you can write down the 8 EY, okay? And then this is you just add all of that part of that, and then you can get the 168. So 168 divided by 8, you can get the 21. So there's a 21 kilonewton. And then to find the AY, just choose the sigma ME equals 0. So now the pivot point for the moment is a E. In the case 5, and then EY cannot create a moment, and then just minus AY times 8. The reason why is that this one actually have a clockwise moment about the E. So that one is this one. And then 2, this one, right? 2 times, and the direction is here. So there's a counterclockwise. Moment arm is at the A. So this one. So same kind of procedure. And then after that, you can find the AY equals 15 kilonewton. So that is the unknown reactions. Now, with this kind of the arrangement, okay, and then determine the force in members BC and HC and HDG. So draw the free body diagram of the section you choose. So we just cut the member this way, and then it's better to choose this side, okay? So left side. And then determine the force FBC, FHC, and FHG using the method of sections. So this slide shows the solution of the member forces. So I will explain this one in detail. So we just cut this member and then choose this left side. And then this is the free body diagram of the left side. So there's maybe you can say the one, and this is for the free diagram for the one. And then in this one, okay, you can see that there's a FHG, right? The FHC and then FBC. Once again, there is assumed intention, the assumed direction intention, right? And then also you put the dimensions. So there's this one's a distance, right? And then 15 kilonewton. You remember that the AY value is that the 15 kilonewton. So that one, put this one, okay? And then we just put all the external forces. And then this one is very important. There's a slope, right? That one, actually this one is the 2, then 1. Because this is 2 meter, it's a 2 meter, and this is a 1 meter, right? And then, so this is once again, this is a 2 meter, and this is a 1 meter, right? So that one, and then this one is the square root of 5, right? So that one. So now we can find the member forces sigma MC equals 0. So I will explain detail this one, and then you can do the other sigma MA and sigma MH, you can do by yourself, but the solutions in there also. Sigma MC equals 0, and then once again, don't forget to write down the counterclockwise, it's a plus for the moment. And then pivot point is a C, so that is the pivot point, okay? So in this diagram, so that one you have this one, okay? That one is a C, and then there's a 2 meter, right? So there's 2 meter, this. So that part of that, so you can see that FBC cannot create a moment because they're passing through this C point C, but and then FHC cannot create a moment. Also, there's a passing through the point C, but FHG, that one is that we actually decompose Y component, X component, right? So that one, FHG, and then 2 over square root of 5, this one. Based on this one, there's a X component, right? So that one is this one. And then about the C, moment arm is at 1, and then clockwise. So that's the reason, minus, and then moment arm is at 1. And then FHG, 1 over square root of 5, that one is the Y component, this one, okay? Y component. And then the moment arm from this one to this one, point C, there's a 2 meter, so there's a 2. And then that one is also about the C, there's a clockwise, so there's a minus sign, okay? And then 4, and then moment arm is at the 2, and then this one is at the 4 is downward, right? So that one is a counterclockwise, so there's a positive sign. And then 2 times 4 also, there's a moment arm about the C. And then don't forget reaction, the AY, 15 kilonewton, that one is a 4 meter, right? And then this one is the counterclockwise. So that there's a clockwise, sorry, there's a clockwise, so there's a negative sign about the C, right? 15, there's an upward, right? And then there is a clockwise, so there's negative sign. So you have this one, and then you can get the minus 24.6 kilonewton with this kind of calculation, okay? And then this is a minus, means that we assume intention, right? So that is the compression. There is a value for this FHG, that one, this member. There is a compression, and then 24.6 kilonewton. Okay? So FMA, the sigma MA equals 0, this one, counterclockwise is at equal 0, the same thing. I don't want to repeat this one, but there's A. Now it's a pure point is A. So pure point is A, okay? There's already messed up, sorry about that. But that one, and then with the free body diagrams, once again, in this case, 2 kilonewton, and then 15 kilonewton about actually the reaction cannot create moment because there's no moment arm. But you can put the 4, and then FHC now, because FBC and then FBC, FHG cannot create a moment because there's a passing through the point A, so there's no moment arm. So there's a FHC is a X component and the Y component also. There's an X component, there's a Y component for the FHC. And then you find it, there's a FHC is at the minus 4.47 kilonewton. That minus sign means that the compression. And then finally, MH equals 0. So MH equals 0, so this point, that point, and then that FH point, okay? And then you also, in this case, it's a little bit easy because there's a 2 times, there's a distance is at the 2 meters. So there's a 2 times 2, and then that one is at the counterclockwise, right? So that one is a positive sign. And then 15, there's a reaction, and then that one is at the clockwise. So there's a negative sign, there's a 2 meter. And then FBC, that one is that no X, just only X component. So that one, moment arm is a 1. So FEC times 1 equals 0. So FEC is at the 26 kilonewton. That is a positive number. So there's a, as we assume, so there's a tension. So that is the entire solution for this problem. Okay? And then definitely your final answer, you just mark the mention of the tension or compression, and then with a box in the data, your final answer for the FHG, and then FHC, and then FBC. Okay, so that's your final answer. Now, this slide shows the practice problem. This problem is asked to determine the force in members ED, EH, and then GH. So you can see that there's a best way to cut this member, right? And then to solve this problem, same reason, there's a support reaction. You need to find this. So you need to draw free body diagram for an entire truss and find support reactions. Then you need to draw free body diagram of the section you choose, and finally determine the member forces. I hope this video is helpful for you. Thank you.